So in this video, we have that Harry has plotted the points A at 0, -4, B at -6, -2, C at -3, 7, and D at 6, 4 on a grid. He then draws the lines from A to B, from B to C, from C to D, and from D to A. Show that Harry has drawn a trapezium. So rather than a rhombus or a parallelogram or something like that. So we need to show that it's a trapezium and not another type of quadrilateral. Now, I would always recommend when you've got something like this and you've got no diagram that you draw a little picture so you can visualize where these points are. Okay, so a quick little diagram just to visualize this. It doesn't need to be very big, just so that you get the idea of where these kind of points really are. So let's just see if I can draw something adequate. How far do we need to go? So to 6. 4, 5, 6. 1, 2, 3, 4, 5, 6. And this only needs to be kind of like small, and then up to 7, don't I? I need to go a little bit further. 1, 2, 3, 4, 5, 6, 7. Okay, right. So the first point, A 0 -4, 2, 3, 4 is there. So there's A. And then B is at -6, -2. So 1, 2, 3, 4, 5, 6, -2, so around about there. Now this isn't going to be accurate, but it gives me an idea of where they are. -3, 7, 1, 2, 3, 4, 5, 6, 7, -3, it's about there. Oh, I didn't do that very well, did I? About there, so there's C, and then D's at 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, so around about there, there's D. Okay, and then he's joined the points up from A to B, so he's drawn on that line, then from B to C, then from C to D, and then from D to A. Okay, so we need to show that that's a trapezium. Right, okay, so kind of looks like a trapezium, but we're going to need to do a bit more work than that. So really what I want to do then is I want to look at the gradients of the sides. If I could show that a pair of opposite sides are parallel, so it's looking like AB and CD, well, AB and DC if you prefer, or BA, CD are looking parallel. So let's find those out. So first of all, the gradient of the line going through A and B. So we've got the difference in the y coordinates, so -2 take away -4, so +4, over -6 take away 0. So we're going to have 2 over -6, so that's -1/3. So the gradient of that line there is -1/3. So let's say that's M is -1/3. Right, now let's find the gradient of BC. Now the gradient of BC is 7 take away -2, so +2, over -3 take away -6, so +6. So we've got 9 over 3, which is 3. So this is 3. So what that's telling you is that because -1/3 times 3 is -1, these are negative reciprocals of one another, which means that these two lines are perpendicular, and so they are at right angles to one another. Now let's find the gradient of CD. So we have 4 take away 7 over 6 take away minus 3, so 6 plus 3. So we have minus 3 in the numerator over 9. And that's minus a third. So this has a gradient of minus a third. So that means that CD and BA are parallel to one another. So we do have a pair of parallel lines. Let's finally look at the gradient of DA, or AD. So we have 4 take away minus 4, so 4 plus 4, over 6 take away 0. So 8 over 6, which is 4/3. So the gradient of AD is 4/3, which is not the same as the gradient of BC. So the gradient of BC is not equal to the gradient of DA. So they are not parallel. So we have one pair of parallel sides, and that's it. And so this has to be a trapezium. So we have one pair of parallel sides, which implies that we have a trapezium. Okay? If it was to have 2 pairs of parallel sides, then we could have a rhombus, or it could be a parallelogram, or it could be a rectangle, or it could be a square. But, and you know, I didn't put this on my diagram, but that's a right angle as well. Okay? But yes, because we've only got the one pair of parallel sides, that gives us the trapezium.